Hi learners, welcome back to DHILK. In this video, we are going to discuss about an important question: why carboxylic acids are more acidic than alcohols and phenols. So here we will be discussing the reason behind this. We will arrange these compounds in the order of their acidity. So watch the full video, and at the end of this session, you will be clear about these concepts. Okay, so let's get started. So first question is that what is acidity? So acidity is nothing but a substance is acidic if it can donate a proton H plus easily. So from a compound, if we can donate an H plus easily, then that compound is acidic. Okay, so how can we define the strength of this acidity? We can define the strength based on easiness of losing this H plus or proton and based on the stability of the conjugate base. Okay, what is conjugate base? A conjugate base is what remains after an acid donates a proton. So, for example, if we have a compound which is RH, then it will remove, if it removes this proton, then what will remain? Then it will form R minus plus H plus. So here this is a proton and this is a conjugate base. Okay, so conjugate base is what remains after an acid donates a proton H plus. Now, in order to compare the acidity strength between these compounds, we have to know the easiness for losing the H plus and the stability of the conjugate base. Okay, so first we can compare with these three compounds. What are alcohols? Alcohols are ROH. Okay, to check the acidity, we have to check how easy to break this OH bond, how much polar this bond is, and how easy it is to break. Clear? And in phenol, what is phenol? To a benzene ring, an OH group is attached. So here what will happen? We have to break this OH bond, and in case of carboxylic acid also we have to break this OH bond and release a proton, right? So what we will get? We will get a conjugate base. So if you break the OH bond, you will get a proton, right? And a conjugate base. So we can just try. What is the conjugate base? ROH on breaking alcohols, ROH on breaking this OH bond, it will produce H plus plus RO minus, right? RO minus. This is the conjugate base of alcohols. Now, in case of aromatic compounds, what will be the conjugate base? The conjugate base will be a phenoxide ion. This is alkoxide ion. Alkoxide ion, and this is phenoxide ion. Phenoxide ion. Phenoxide ion or anion. Then in carboxylic acids, if you break this OH bond, you will get carboxylate ion, that is RCOO minus. That means this is carboxylate anion. Carboxylate anion. Okay, these are the conjugate bases of these three compounds. Now, in order to compare the acidity, we have to compare the stability of these three conjugate bases. Okay, now look at this. This shows the formation of the conjugate base of alcohols. Okay, so here for this alkoxide ion, there is no resonance possible, right? Only one simple structure is possible for alkoxide ions, and the negative charge is on the oxygen atom, and it is localized on this oxygen atom because there is no resonance possible. But in the case of phenoxide ion, so this is for alcohols. In case of phenols, the phenoxide ion, it is ARO minus. Here this negative charge can delocalize through this benzene ring, and it has totally 5 resonance structures possible, right? If resonance is possible for the conjugate base, then the conjugate base is stable. Okay, so here conjugate base has 5 resonance structures and the negative charge is delocalized through the system. So compared to alcohols, phenols are more acidic. Phenols are more acidic because of the resonance stabilization. Now we know that phenols are more acidic than alcohols. Now we have to compare in between phenols and carboxylic acids. Okay, so this is phenoxide ion, this is carboxylate ion. So for carboxylate ion, there is also possibility of conjugate base to undergo resonance stabilization. Look at the structures. Carboxylic acids, on formation of this conjugate base, there is a chance that there are 2 oxygen atoms. So this negative charge can delocalize, and one thing is that the negative charge on more negative oxygen atom. Here the negative charge is on carbon atoms, right, in phenoxide ions, but in carboxylate ions, negative charge is on oxygen atoms. And more than that, look at these two resonance structures. So here the negative charge is distributed in between two oxygen atoms, and there is equal distribution of charges, right? So we can write this resonance hybrid. So the negative charge is shared between two oxygen atoms and they have equal distribution. So because of this reason, we can say the conjugate base is more stable. Okay. One more point is that the oxygen atom is electronegative, right? So here oxygen atom has a minus I effect, right? So what is the benefit of this? Because of the minus I effect, it will withdraw electrons towards it. Oxygen atom will withdraw electron density towards it, making the OH bond more polar. This further stabilize the conjugate base, right? Because of the minus I effect, minus inductive effect, oxygen will withdraw electron density towards it, and it will make this conjugate base further stable. Got it? So because of these reasons, carboxylic acids are even more acidic than phenols. Okay, now we can compare between all these three compounds. So what are the conjugate bases of alcohol? Alkoxide ion, this is a phenoxide ion, then the carboxylate anion. So charge location only on oxygen atom in alcohols, while in phenols it is delocalized into benzene ring, but in carboxylic acid they are shared between two oxygen atoms. And come to the resonance stabilization, there is no resonance possible in alcohols, while in phenols resonance is possible because of the ring delocalization. But in the case of carboxylic acid, there are only two resonance possibility, but they are strong and in between two oxygen atoms. Charges are shared between two oxygen atoms and they are equally distributed, right? Because of that, resonance stabilization is more stronger in carboxylic acids. And what about the charge distribution? In alkoxide ions, it is localized, while in phenol it is partially delocalized, but in carboxylic acid they are highly delocalized and there is equal sharing, right? Now come to the inductive effect. In alcohols, inductive effect is very weak, while in phenols it is moderate, while in carboxylic acid there is a strong minus I effect, right? Then what is the stability of conjugate base? Because of all these reasons, alkoxide ions are less stable, while phenoxide ions are moderately stable. At the same time, carboxylate ions are most stable. Now, because of these reasons, we can say what is the order of acidity? Carboxylic acids are more acidic than phenols, than alcohols. So just remember that if more resonance and more electronegativity atoms, it will increase the stability and make the acid stronger. Okay, now basically we can say alcohols, there is no resonance or least acidic. Phenols, they have resonance stabilization, moderately acidic, while in carboxylic acid, along with the strong resonance stabilization, there is minus I effect also, so it is most acidic. Okay, I hope you got these points. So make sure rewatch this video if needed, practice the concepts, get fully comfortable before moving on. If you are a class 11 or 12 NCERT student and want complete materials, notes, tips, tricks or live classes, one-on-one sessions, visit our website or contact us through the number. Check the description box or comment section for more details. If you found this helpful, don't forget to like, share and subscribe and turn on the notification bell. Thank you for watching. See you in the next video.